Awkward silence. Hello, Alessandro. Yeah. Hello, everyone. Welcome to ARM Innovation Coffee. Today is a very exciting episode. First of all, though, Alessandro, cheers to a beautiful day. Oh, there you go. Cheers to a beautiful day. And hello, everyone. Welcome. Today, as I'm sure a lot of you know, because you saw our Twitter posts and our stuff on Discord, we're going to be meeting with Bruno Verhachten, who's going to talk to us about the edge in the real world. So this is ARM edge compute in the real world. Something really cool about today's episode is that he gave an amazing presentation last year during Linaro Connect, and we get to see the extended version of this presentation. As you know, technical sessions are usually, 20, 25 minutes, but I'm told his presentation was actually meant to be longer. So I know a lot of people enjoyed his presentation at Linaro Connect. You're going to get to see a larger or longer, more extended version of this, like watching the Lord of the Rings 4-hour long movie, right? All three of them. So, but before we do that, Alessandro, we had a really nice guest last week too. And as we like to do during the show, we like to offer a recap. So if you wouldn't mind.
Yeah, absolutely. So last week we had a really cool guest. He was from Microsoft Azure. It was Olivier Bloch, and we talked about how to simplify IoT development. It was a really interesting show. I mean, there was a lot of cool stuff that Olivier went through, and he actually had 2 demos. So usually we get 1, but he had 2. So it was a fun show. Go check it out. We'll put the link in the description.
Awesome. Thank you, Alessandro. And thanks to Olivier for joining us last week. I'm told we'll get him on the show again at some point. Cool. So I think without further ado, let's bring Bruno in. Bruno Verhachten, as I mentioned, gives great presentations, but not only that, he's a pretty amazing ARM developer in our community. So welcome, Bruno. How you doing?
I'm fine, thank you. Thanks a lot for welcoming me and having me in the show this week. As I said before in my tweet, it feels kind of weird to be on stage instead of in the audience as every Thursday. But anyway, we'll do.
Yeah, we're excited. We're excited. Cool. So yeah, welcome.
Cool to have you here.
Yeah.
Thank you.
Before we go into your presentation, I think it's important to kind of build a little bit of that credibility of the stuff you're going to be teaching us. So if you wouldn't mind, could you tell us a little bit about yourself and what you do in your time, your free time?
Oh, in my free time, and also a little bit at work. It's not my main subject at work, of course, but I've been interested in ARM devices and more especially SBCs for quite a few years, I think from 2016, something like that. So in my work, I work with SBCs for continuous integration, also for Android test device farms, also for video, and of course a little bit about the edge computing we'll be talking about today.
Awesome. Very cool. Yeah, no, very excited. So, I mean, if I just want to remind everyone who's watching, because the way this is going to be structured is slightly different than what we've done in the previous Innovation Coffee, since Bruno does have a presentation for us. He has promised to leave little gaps so that we can ask questions. Now, if you're in the audience and you have a question for Bruno, please post it in the chat. Alessandro and I will be monitoring that, and we'll bring those questions right to Bruno. Also, as he did mention, he's done a lot of stuff with CI/CD and the Android farm. So if you have questions around that stuff as well, I'm sure he'd welcome those as well.
Yes, of course.
Cool. All right. Well, Bruno, we're here. We're ready.
Oh, okay. So let's switch to that and see if that works or not. Yes, it does. Okay, cool. So, welcome to this special presentation. So, it's been around for years now, but I think it's slowly becoming the template of a silent evolution. Raspberry Pis have been there like forever, but I think it's more about 8 or 9 years now. And they have sold like hotcakes since the beginnings. So I'm sure lots of you have already used a Raspberry Pi. More than 30 million have been sold, and I'm sure more than that to this day. We have all seen them working as a cheap alternative to a desktop computer, helping children to get a taste of IT or help to automate things. But they can be more than that and less than that at the same time. So let's see to try to have a look at that together today. So as Robert said, I'm Bruno Verhaegten, and I work for a French payment company, but we don't care about that presentation. Now, a few definitions. So the Internet of Things is a network of devices such as vehicles and home appliances that contain electronics, software, sensors, actuators, and of course, connectivity, which allow these things to connect, interact, and exchange data. There are Bluetooth-enabled forks which vibrate when you are eating too quickly. There are internet-connected umbrellas which alert you if it looks like it's going to rain. There are even toilet paper dispensers that can sense when you're running low and that will notify you via an app. If you want your toaster to tweet when your toast is ready, we got you covered. But IoT is not a toaster, not a refrigerator. At its core, IoT is really just about sensing, controlling, and interacting with more of the physical world in a connected way. So the first point is sensing. Data drives decisions. So whether dry soil needs irrigation or freezers need to be serviced, having better information about the physical world around us can help solve problems. A huge part of IoT is about getting this information to the machines that need it to solve the problems automatically. So most of the work in the IoT sensing space involves figuring out how to replace the human in the loop, sensing, metering, and measuring processes with automated ones. So the second point now is controlling. Once data points a machine in the direction of a problem, the best outcome is often for automated processes to kick in to solve the problems. Sure, this can go horribly wrong if systems are not well designed. But the true return on investment for more and better sensors is automated control. So this could be as simple as turning on the sprinklers when the soil is dry, or as complicated as adjusting regional power grids to compensate for the loss of power from solar panels that just went under the shade of clouds. The third point now is interacting. So this is where the human gets back into the IoT loop. Wherever we provide information to a machine or make an electronic decision that affects something physical, we are interacting with the Internet of Things. Now, edge computing. So it brings memory and computing power closer to the location where it is needed. As Wikipedia says, it's a distributed computing paradigm in which computation is largely or completely performed on distributed device nodes. So edge computing pushes applications, data, and computing power away from centralized points to locations closer to the user. So this is way different from cloud computing, where the data, the images, are sent to the cloud to be processed, and an action is performed afterwards. But why should we work at the edge? Why not use the cloud? It's a general tendency these days, and the first reason would be the latency and the bandwidth. So if your IoT is waiting for the answer of an API, you will have enough time to get into trouble. There are cases where the response time is really critical. Moreover, if you have tons of devices connected to the very same network trying to push data to the cloud, the effective bandwidth will be reduced. The second reason would be security and decentralization. So commercial servers are subject to attacks and hacks. So if your edge computing device is not super easy to attack, then it will be harder for attackers to bring down an entire network of your devices using a DDoS attacks than with a centralized server. To counterbalance that, badly protected IoT can then become zombie machines able to be part of a DDoS attack. The third reason now would be customization. Let's say that I run a factory that produces toys. It comprises 100 workstations, and to check the quality, I would need an image classification at each workstation. But each workstation has a different set of objects, so that training one single classifier could not be the most effective way of classifying these objects. So I could have several classifiers on the cloud, which would be expensive, and I'm cheap. So why not have a custom classifier at each workstation meant for cheap? There are also other reasons like redundancy or cost effectiveness, but I won't detail it here. By the way, do you know that you are already using machine learning at the edge every day? Now, we have the definition or my definition of IoT and edge computing. Could we transform our Raspberry Pi into an edge computing node, an IoT on steroids, or anything in between? Tens of thousands of people have made LEDs blink thanks to Raspberry Pis, and lots of them have done way more ambitious projects like a self-driving robot, and new ideas and projects surface just about every day. Be it building a supercomputer by stacking lots of SBCs, Bitcoin miner, brewery system, home automation, weather station, or any crazy idea. The only limit seems to be your imagination. As we are at the end of the first chapter, if you ever have any question, Robert, Alessandro, I can answer them if you want to.
I actually have a question here because
Really?
you brought up, I mean, you brought up decentralized nodes, you brought up cryptocurrency, and I mean, I have to chime in. I'm
of course. Damn it, I made my first mistake.
Yeah, not only that, I mean, you know, we're talking about cars, communicating with each other. I mean, I look at a car as kind of like an edge device, right? This car, it's traveling down the road. It's an edge device. It has a bunch of sensors. So first question here, I mean, something that comes to my mind when we're thinking about all these autonomous vehicles on the road, they're using all of these sensors to detect lanes, to detect the cars next to them. I'm kind of curious what your take is on once we hit this level 5, right? Like AI level 5, where these cars are able to communicate with each other. I still feel that we're going to run into these latency issues where all these nodes need to communicate with each other. But are they going to be able to communicate with each other in real time? Are there any hurdles we need to overcome there? I mean, to that regard, and I don't know if I'm phrasing my question properly, but this is just something in my head. It makes sense.
Yeah, I got your point. I'm no expert in that domain, not at all. But yes, I think we still will have latency issues between all these edge devices moving around. So I don't know if any standard will be thought of before this level 5 happens. But yes, this is something we will have to think of. I say we, but I am not implied at all in these technologies.
So Alessandro, sorry, did you have something to ask? Because I have another one, but go ahead.
No, I was just gonna add on that. You know, it's an interesting discussion. I think one aspect is, you know, there's people looking at how do we create redundant systems so that, you know, if the communication fails, the car is driving autonomously, the communication fails, it's still able to operate so that, you know, without failing, maybe without failing the brakes or whatever it is, because actually it's running some redundant system, autonomous systems on the edge, right? And that's kind of like, to your point, Bruno, by doing the edge processing, you are able to kind of avoid that latency issue, right? So that's definitely interesting.
Yeah, I think, and I'll just comment on that. I guess my next one wasn't so much of a question, but a comment. I think also it depends on the amount of nodes you have at the edge, right? I mean, you can kind of see this as an example with blockchain technology. If you take a distributed network and you put tens of thousands of nodes and every node needs to be updated every time there's a change, well, that's going to take a little longer. But if you reduce the amount of nodes, then it can update much quicker, right? Reducing those latencies. But yeah. Cool. I'm looking at the chat. I don't see any questions yet. Belina did comment, say machine learning, at the edge, ? But I don't know if that's a question. So yeah, I think we can.
Oh, so Belina is there. Okay. So we will have to have a what's on your desk moment at the end of the show. We'll see.
There you go. They're putting their coffees up. Belina is putting their coffees up. You can see it on the screen.
Great.
Nice. All right, let's move on then. We'll make you big again. Thanks, Bruno.
You're welcome. So now you know of the Raspberry Pi, but lots of competitors have appeared since then and somehow managed to follow the same recipe, which is stay cheap, which I love, use the ARM architecture, and don't forget to add GPIO to interact with the outside world. And of course, run Linux for most of them. Some of them keep the same pi suffix to show they're part of that same impulse, like the banana pie, the orange pie, and some others stay on the plum theme, like the pine 64, and others plays on suffixes to be visible, like the Odroid. The last ones have a personality of their own, like the beagle bone. I have not yet understood why it's called like that. But anyway, so to do the same kind of things that we do with the Raspberry Pi, we could use an orange Pi SBC, but we could have chosen another fruit like the banana, a rose apple, or any other edible theme SBC like the potato, or something even less palatable like a pine cone. Not so good. Whatever floats your boat, as long as the card supports a recent version of the Linux kernel, and who knows, maybe Docker, that could be interesting. There are lots of different cards to choose from, so you have to make a list of your prerequisites before ordering one. How much memory would you need? 256 megabytes, 4 gigabytes, anything in between, or even 8 gigabytes now with the Raspberry Pi 4. Should it have a GPU, NPU, FPGA? What about the storage? Good, old, not so good, SD card, eMMC, M2? Should it have camera input, HDMI output? Nothing at all? And regarding the network, should we use Fast Ethernet, Gigabit Ethernet, Wi-Fi, LoRa, mobile broadband? Would you need USB? And what about the GPIO pins? Should it be able to use a real-time clock? Would you need it to be battery operated? And what about the operating system, Linux, Android, or something more exotic? Now, what about OTG? And do you need a recent kernel or not? Would you need a specific hat, a cap, mezzanine to extend the features of the card? Should it be able to run Docker? And there is no one-size-fits-all in the SBC field, so you have to choose your weapon. Now, I don't think there are already some questions because it was still vague. Don't hesitate to interrupt me, Robert, Alessandro. Nothing? We can go on?
Yes, please continue. Looking good.
Well, we do have, Robert, we do have a question, actually. Should we ask that question
Let's
now?
do it. Bring it in.
Time? Is it time? You're probably expecting this. Oh, no, sorry. Wrong one.
Okay.
Here we go.
Sorry about that. So,
how did you get your name?
What's your name?
How did you get your name, Podding?
Oh, this one. Okay. I will try to make it short. David W, I guess.
Yes, that's from David W.
Okay, David. Well, so to make a long story short, in 2014, I was trying to set up a virtual Android device farm, with VirtualBox machines based on the port of Android, which was called, and which is still called, Android x86. Anyway, I had some troubles at that time with network and VirtualBox, but we don't care. So Android's versions were still called at the time with sweet names, KitKat and so on. And at the time, we were still at the letter K, so KitKat, and we didn't know yet what the name of the next version of Android would be. So I decided I would name my project with the next letter in the alphabet, so the L, and I wanted to promote a local sweet that we have in the north of France, which is a tart, which is called Libouli, which means milk, which has gone until 100 degrees or something. Anyway, so it's tart based on milk. So the project was called Libouli. Then, in 2017, I think, I decided to make a real Android device farm. And at the time, we were at the letter O for Oreo. Then I tried to find something starting with the letter P. And once more, I decided to promote dessert sweet that we have in the north of France, next to Dunkirk, for the people who know Dunkirk. And it's called Podding. It's a cake with old bread. It's delicious. For me, it's delicious. Anyway, yeah, and I like the Podding so much that I published my project on GitHub and so on, and talk everywhere about that Podding project. And so that project became my name on the social networks and so on, because I'm kind of proud of this project. Sorry, I made it quite long.
It's more popular than the chocolate. Like I search in Google, I can't even find the chocolate. I only see you. Or
yeah. Okay. You know what's actually the name translates. I mean, if you change basically 2 letters, right? It changes to pudding, right? Like, or no, maybe you have to change a few more. But it's the same. I just realized when you were saying it, I was like, oh wait, it's actually pudding, right? Like it's just a French version of it, right?
Pudding.
I like the motivation behind it, though. I do remember when Android releases were named after the candies, or named after candies in sort. So that's pretty cool. And you were kind of following the process there with the letters.
Yes, every time I was wrong. The 2 times I was wrong because Libuli was not chosen and Podang either. Hopefully.
Yeah. I mean I've never heard of either. I'm not surprised. Sorry that those weren't chosen. But
of course.
Yeah. Okay,
cool. Just while we're here, I mean, David W is actually saying something else. He's saying, "What? No more heads up." Actually, while he's here, get him to commit for the Innovation Coffee 24-hour episode in the future. Are you up for that?
They're still calling us on that.
Why not?
No one. He's committed. It's recorded.
He's committed. It's done.
Yeah. Cool.
And actually, sorry. Last thing on this. I shot JR is saying for a 24-hour stream, we have to ship everyone pudding to eat. Fair, right?
Give it a shot. I can't even find what it is. It's Bruno's so famous. Literally, my entire first page of my Google search has nothing to do with what pudding is. Yeah. All right, cool.
So going back to SBCs then. There you go.
Yes.
Thank you, David. So, now the SBCs. So they are little, but they are powerful. They can be used as real servers, even if that's not industrial servers. They run Linux. After all, they have fast Ethernet or gigabit Ethernet. Of course, they don't have 10 gig Ethernet, but they have plenty enough memory to run a web server, a small database, a weblog, a NAS server, a seedbox, a home media server, or any kind of server, as long as the software you need is supported. The possibilities are endless. We have all seen that, a blinking LED plugged into a breadboard linked to Raspberry Pi. That's almost the first mandatory step when you want to interact with the outside world. Though the number of difficulty levels is quite high. I don't advise you to run your nuclear power plant with sensors plugged into Raspberry Pi GPIO, but having your own Raspi drone sounds pretty cool. Lots of intermediate levels give you instantaneous satisfaction, like home automation. You can add a coolness factor by using trendy devices like the Echo, Google Home, Alexa. You can even build your own Alexa or Google Home thanks to SBCs. Okay, I can go on. Docker has been quite a craze for a few years now. It's used almost everywhere and mostly on big x86 servers. I use it every day. I must admit that it made my life easier as a developer. With Docker, you can run the same software as you would without it, but so much easier as the configuration and the dependency hell have already been done for you. It will run the same way on your development laptop or any virtual machine or on your shiny and expensive server. You can also run several containers at the same time with Docker, so that you can host several services on the same host without interferences. So who has never experienced having dependencies clash when trying to host several different services on the same host? I have for sure. For years, Docker has been used only on big x86 servers, but after Resin.io, which is now Belina, hello David, everything changed. You could then have a running service on ARM without having to reinstall the whole system in case of an update. Rollback is much easier when using Docker, so you can now use Docker on your new big ARM servers. But you are not limited when using Docker to the biggest ARM servers. Even the Raspberry Pi can use Docker. By the way, Cypriot ARM Linux distribution has made Docker on ARM its main selling point. From burning the image on an SD card to the first Docker container running in 5 to 10 minutes is for real and not just a charming promise. It even exists in 64-bit for the latest evolutions of the Raspberry Pi. For other cards like the Orange Pi Zero, which I love, you can use Armbian, which makes the installation of Docker a breeze. So that's pretty cool to be able to run Docker on that kind of mini machines. But what kind of service could you run on Docker with so little memory? Well, tons of things. Believe it or not, you can transform your Docker ARM machine into a web server, a database, a blog. As without Docker, the possibilities are endless. So we've seen that we can make tons of funny and interesting projects with a Raspberry Pi and its competitors, use them as servers, interact with them thanks to the GPIO or hats, and even use Docker, which will help us get out of the dependency hell, all thanks to recent top-notch distributions like Cypriot OS, Armbian, or the Lina OS. For other cards like... what now if we could combine that? So could Docker show some love for the LED? We will try then to combine the best of both worlds. So should we make a pause and answer to comments or questions, or is that okay for the time being?
I kind of want your view on Docker as of late. So Docker, I mean, huge community of developers. I think like in the millions, right? So I'm kind of curious, how you view Docker moving forward. I mean, they have the Docker desktop, Docker CLI. Things have been going forward for them to that regards. But I mean, you also have their parent company, Mirantis, right? So, I mean, how do you view this Docker developer ecosystem evolving, going forward?
Tell you the truth, I really don't know. As much as I love using Docker and so on, I think that some people are not that happy with the way Docker is evolving and the craze about Docker. Lots of people are looking for alternative solutions, and even Kubernetes lately in the 2 weeks or maybe 1 month ago said it was the end of Docker, and it was not that kind with Docker project and so on. So I don't know how all that will evolve. We have several choices now. We don't have to use Docker everywhere. We can just use Containerd or whatever other container technology we have available. So I really don't know what will happen. And did we reach the maximum? I don't know.
I've been asked, I mean, I've just been asked by several people, like what my thoughts are. I have my own thoughts. I'm not going to share them on the stream, but I do think it's important that we ask, our guests and other people in the community what they think. And so, also I should say, if there's anyone, listening right now, please drop a comment in the video as to your thoughts on the Docker developer ecosystem. So thank you on that.
And to add to that, I'd like to actually ask you, Bruno, you mentioned there's other containers technologies. Could you share maybe your experience with one or two? Like, is there any others that you've tried, and what is the benefits of others, perhaps?
Unfortunately, not. I invested so much in Docker these last years that for the time being, I have not yet tried anything else. I've read quite a few articles, people discussing about that. I saw, for example, I can't remember where, but anyway, discussing about why Docker is not such a good idea and so on. So I have to try some others, or just trying Containerd directly without Docker. I didn't find time for the time being to investigate into that field, but hope to do it some of these days, just in case Docker would die. I would have to find another solution so that my projects just don't stop. But I know it won't happen tomorrow, but I have to think about it. So no, sorry, I haven't investigated yet.
Yeah,
thank you.
Heard some good things.
Don't hesitate in the comments to tell us what you think could be the most interesting other technologies of containers to use on SBCs with as little as 512 megabytes of memory. I'm all ears.
We need to mark that moment on the video so we can because go answer Bruno's question at that minute. Yeah,
let's repeat that actually. So what is the question? So what other technologies, container technologies, do you find interesting? And Bruno, you gave an example, technologies that are actually capable of delivering containers to, what did you say? What was the memory footprint?
512 megabytes of memory, like we have with the Orange Pi Zero or other versions of the Raspberry Pi.
So any thoughts on that would be useful.
Yeah. Cool. And David made a comment that everyone needs a big ARM server. I think this was regarding your ThunderX comment. So cool.
Yeah, I once had access to ThunderX too. I lost it. I think it was a gift from Ed Vielmeti from Packet, which is now not Packet anymore, because I wanted to port an open source project to ARM. And so he lends me an access to ThunderX2, and whoa, this thing was amazing. I can't remember how many terabytes of memory it had. Terabyte? Oh, I don't know. It was huge. And the number, of course, was just crazy. You just had to push on the enter, gun on the keyboard, and it was already finished. That thing is crazy.
We still have a program where you can go apply to get access to one of these big servers for, we'll call it for free, but it's subsidized, right? Excuse me.
Yeah.
It's the Works on ARM program, and I'll share the link right here in the YouTube channel. This is Works on ARM. It's a GitHub repository. You go there, you open up an issue.
Open an issue, yeah.
Tell us what you want to use it for, and we can maybe get you access to one of these servers. Recently, during the ARM Dev Summit last year, we gave 6 months of this away, and it just turns out, you mentioned Armbian. Some folks from Armbian actually won that 6 month. So we'll see what they end up doing with it. But I mean, it's pretty cool because Armbian is now, I guess, testing their builds on one of the Works on ARM servers. So pretty cool.
Yes, you're right.
Yeah.
Yes, indeed. And I followed the same procedure. I opened an issue on GitHub on this very repository you mentioned, and that's why I got the access to the server. But we also need some ARM workstation. I think the audience will be okay with that.
Let's do it. All right, Bruno, you're big again here.
Okay, let's go on. So, can we get the best of both worlds? I mean, a blinking LED controlled by a Docker container. Okay, this may not be the best use, but you get the idea. As soon as you think of what you could do if you could control from within Docker what's going on with GPIO, ideas will pop up by themselves because, yes, you can control the GPIO through Docker. You can prepare ahead of time an image containing everything you need. You can break it as many times as necessary until it works fine, and then deploy it on an innocent machine, which is linked to a piece of hardware, without having to tinkle with a machine configuration. So I don't know if David, if he is in the audience, but for example, Balena OS is typically what you would use to do that kind of things if you are the owner of a fleet of SBCs. You could have, for example, a sensor connected to Raspberry Pi, ready to be read through Docker. There are several ways to do it. You can choose your favorite GPIO library and create your own Docker image with it, or use a pre-made Docker image containing a GPIO library. Afterwards, you just have to run the chosen Docker image, while not forgetting to link TTY-MI0 to TTY-MI0 and devmem to devmem, which will give something like this. Easy peasy lemon squeezy. Being able to interact with a sensor, a hat, or any hardware plugged into a GPIO is a major step. If we could add on top of that, capturing images through the CSI camera with Docker, that would be the raspberry on the cake. It's not a pudding, for anyone asking. Is it even possible? For those of you who are not yet seated, if you would like to take a seat, because of course it works, you have access to the CSI camera from within Docker. You can access it through Docker, and there are even Docker images ready to use that will launch a web server serving the video that will open a port with a video streaming. That's another nice step in the right direction. You just have to link the right device to your Docker container or run it as a privileged container. So what do we have now? A Docker-able ARM machine ready to be used as a server that can interact with the outside world. It can make some heavy computation or even AI based on the data it gathers from the sensors or from the camera, so that we can do anomaly detection or forecast, for example. We can also report on specific hardware, for example, like your lava lamp for failed build or a Google Home notification message. That's interesting, but can we do any better? With this configuration, we still have to use a power plug, Ethernet, Wi-Fi, so that we're not really on the edge of anything. Could we simplify or make the device more independent? Some devices can handle PoE natively with little hacks or hacks that you could get rid of the power plug and let them operate about anywhere as long as you've got Ethernet nearby. We still have to be next to a plug of some sort, of course. What if we remove the power adapter limitation? So the Pi juice for the Raspberry Pi, for example, could be the solution if coupled to a solar panel or any other solution that does not depend on the grid. For others SBC, there are other solutions, some crude. This is mine. I'm not really proud of it. It's just made with some off-the-shelf parts. We can talk about that later on. But most of the time, it looks almost the same, unless for this one. A mezzanine of some sort, hosting a battery on top of the main card. We're not far from happiness. No more warriors of power, and we could get rid of the Ethernet too, but we still depend on the Wi-Fi, which may not be convenient depending on the location of the device. So one last upgrade to a device on the edge could be the use of LoRa. But if you don't mind, we could just have a little chit-chat about what I just said regarding the power, if you're ever interested in knowing more about that. By any chance, would we have any question regarding that, or not at all?
So we haven't gotten any questions on this. I think people are entranced with your presentation. I'm thoroughly impressed. Also, just kind of like, it's so fun to follow because you're entertaining and you're very knowledgeable. So this is great.
I see a change of scenery there. Wait, should we put something up here?
Wait a second. It's not time for
Wait a second. Is it time?
No, it's not time for that. I just wanted to make a short.
Let me take it off then.
No, we can't see it. We can see it. That's not a problem. I just wanted to show just a few things because I was talking about power limitations when you're on the grid, and now we want to get rid of that. So I want just to show you two little gizmos that I have at home. So this one is a simple solar charge controller because I have a solar panel outside, and my goal was last year to have, at the end of the year, one SBC running just out of solar power and hosting a website. Unfortunately, with the lockdown and everything else, I didn't manage to do it, but it's quite cheap and it's pretty dependable. You just have to source a car battery, and you're good to go with a solar panel. And I also wanted to show you something else, which is pretty funny to me. It's a turbine, which will produce 5 volts. This one will produce 12 volts because I chose the wrong model. But anyway, you could hook up SBC just next to your kitchen sink and have the power coming from the water. That's pretty amazing. By the way, I have one under my kitchen sink, but my wife doesn't know yet about that. So shh, just for you. I was trying to show you something. Yeah, that's the one I wanted to show. Come on. Where are you? Oh, there it is. So the thing I just show you, is the solar panel charger and the hydroelectric turbine. This can be used to charge that kind of board. So on the very left on the picture, you can see an Orange Pi Zero, for example, and you also can spot a 18650 battery and other cards that will give some power to the Orange Pi Zero. Just wanted to tell you that I'm experimenting with that. I'm no expert at all, and I'm just using off-the-shelf parts. That's why it's but ugly.
You gave me such a good idea. Sorry, you gave me such a good idea right now. So, like, I'm a huge fan of solar power, renewable energies. I've built several of my own mobile power stations, right? Like one I actually did with David Tichler. But gosh, I mean, with these kind of water turbines, I'm not, maybe people thought like, oh, hey, I'm just going to turn my sink on and, run the water down. That's a waste of water. The goal would be to literally put this under your sink so that the water that's already going to be wasted at least turns into energy. And so you can have like a battery storage under every one of your sinks that collects energy and or funnels it into your system, however you want to do it. But then the water's not wasted. You can even put that through to when your toilet is filling up with water or whenever. Like, I mean, every single bit of water being used could be turned into energy. That's
so
very
I don't have it in the toilets, but I have it under the kitchen sink. Yes, it's not plugged into my kitchen tap, but under, just before the kitchen tap, so that we are putting some pressure reduction gizmo in order to not waste any water. You want the water coming out of the tap not to be too heavy, because you want to save some water. So with that kind of turbine, the pressure is going down anyway, so that's not a problem when you want to use a kitchen sink or on the toilet. That's also not a problem. There are lots of places in the house where you could just grab some energy and use it maybe to power SBCs or just recharge 18650 batteries.
Well, it'd be the best to power SBCs, ARM-based SBCs.
Yes, I have one. To tell you the truth, I have one under the kitchen sink linked to that hydraulic turbine. The problem is I didn't plug everything in. As you can see in the picture, there are some links mixing. So when the power of the battery is not good enough, the SBC doesn't know about it. So it just dies. And the SD card doesn't like that at all. So when everything will be plugged in, or when A13 will have finished all the ideas I gave him, we'll see if we can have something that works and which stops beautifully and not like it does now.
I think a lot of it has to do with kind of you calculating how much energy is produced, what do you need to store, and then using that charge controller to make sure that when there's a surplus, it pulls from the battery, and when there's no surplus, it pulls from the actual energy creation itself, right? So, I mean, the charge controller is the brain. But we could talk more about that on another time. Let's continue the presentation here. So,
yes, sorry.
Yeah, that's awesome. No, I love that. That's cool.
Okay, thank you. So now we're talking about Ethernet, Wi-Fi, and now I will introduce LoRa. So this technology allows very long-range transmission, supposedly like 15 kilometers, which is about 9 miles in an open field. I know that some people have made way more than that, talking from United States to Netherlands and things like that. But you can expect 9 miles in an open field, which is way less than that in cities, of course. And it has a way low power consumption. So, of course, you have to be able to get in touch with a LoRa gateway in that range. And the data rate is not super exciting. I think it's around 27 kilobits per second at most. And you're not allowed to occupy the bandwidth all the time. So it won't be the answer to all our questions about using a Docker-able ARM machine on the edge without any access to the grid. It will never allow you, for example, to send pictures that were taken by the camera, for example, but it could send results about what it found in the pictures. Your sensors, devices, motors, sprinklers, whatever equipped with LoRaWAN will send data the gateway they can reach, and these gateways will send this data to an application server, which will then get in touch with your code thanks to MQTT or HTTP, for example, that knows what to do with this piece of data. But I'm talking of LoRa, but if there are any way to use LoRa easily with a Raspberry Pi, yes, indeed, you can find hats to transform your WASP into a LoRa thing, and even the Raspberry Pi Zero. You can also transform your Raspberry into a somehow limited LoRa gateway with that very same card, or spend more money and have a full-fledged gateway instead. Now we're talking. We have a low power, off the grid, ARM device running Docker and able to interact with the outside world while exchanging data with the rest of the internet and the LoRa devices around him. That's not bad. But is that really computing at the edge? I think it is a nice blend of IoT and edge computing. I know lots of people have lots of different examples of what is IoT, what is edge computing, where does IoT stop, when does edge computing start. And I think that maybe that solution, it's not industrial at all, but it's in the middle of the gate, in fact. It's a blend, mix of IoT and edge computing. Of course, Raspberry Pi are not Server certified and Orange Pi either, but that's interesting nonetheless. But speaking of LoRa, why should we bother with LoRa? Couldn't we use directly GSM on the SBCs? Of course we can. Some USB keys that provide GSM connectivity are handled by Linux on the Raspberry Pi. Some SBCs have mezzanines with SIM card slots so that you can get network this way too. And some other cards have directly a SIM card slot and lots of other gimmicks too, so that you could start sending your data on the internet just after unboxing your card. But will there be a good 4G connection where your device will be located? And are you ready to pay each month a fair amount of money for your IoT device to get access to the internet? What about it getting stolen? So why not get a cheaper subscription and just send text messages? So 2G is widely available even in the countryside, but at least in Europe. But you would then have to be able to catch the messages on the other hand, so maybe at home, so that you're able to process them. And which means another card with another GSM subscription and tons of headaches. And another drawback of using GSM is a power consumption. Sending an SMS is way more energy consuming than sending the same message with LoRaWAN. In fact, I've seen some studies that prove the opposite. So take it with a grain of salt. But using LoRaWAN is just a matter of finding the right card, hat, USB key, and being part of the right network. But once it's done, you won't have to pay each month to get LoRa on your connected part of the world. LoRaWAN gateways are here for you, forwarding the packets to your application server automatically. You already got it. I'm cheap. And LoRa has been designed to be as cheap as possible. So cheap, in fact, that you could get LoRa-able sensors for very little money. These sensors could send to your LoRa gateway-able SBC data that it could then process and forward through the core network to your application server. It's so cheap, dependable, and disposable that even cows get some. I know we are not sheep, nor cows, but if cows can get some, we should too. Maybe not on our ears, but in our cities. So what do we have now? Another grid, SBC, able to process some data to interact with the outside world by using sensors, cameras, or maybe even engaging mechanisms, starting motors, and even being able to get and send back data to your application server. We could have several of them acting as end nodes, processing images, sensors data, taking decisions, or drawing conclusions, and sending back data to others acting as gateways. Now what? Would we have any question or comment?
I don't see any that have popped up, but Stas does mention that wireless cows, that's the future.
Yes, it is. And printable pizzas also.
Yeah. Oh, I want printable pizzas, please.
Oh, I'm so hungry.
I've got a question.
Yeah, go on,
Bruno. In your experience, so you mentioned you talked a lot about LoRa here. What about the other? How would you kind of go about choosing perhaps communication means like LoRa, Sigfox, Zigbee, and BIoT. Like, what would you, why would you pick one over the other? I mean, how would you go about asking yourself whether one is better than the other for a specific application? Or do you have a preference yourself, I guess?
Yeah, you got it. I'm cheap. So my preference would go with LoRa for that very reason. But I know I'm not specialist at LoRa either. I tried it. I love it. But I have some colleagues at work who are working with Zigbee, LoRa, and so on, and would be way better at explaining why we should choose this technology and not the other. The thing is, we are always talking about LoRa with these colleagues and never about the other technologies for whatever reason. It's not just because I'm cheap. It's maybe because the things I want to do are more easily doable with LoRa than with the other technologies. But if anyone in the audience knows something more about the technologies you cited, just let us know so that we can have arguments. Why would it be better to choose something else than LoRa? For me, it's just about the power consumption and the thing. It's free and open, and you can find easily around your place LoRa gateways able to receive the data you produce. It's kind of easy. And there are several networks. There are the Things Networks. In France, we have the Bouygues Telecom network also. So I don't know what the status in America or in England for you, Alessandro, or for anyone else in the audience about the availability of LoRa networks or other networks.
I think that's usually how it works, though. You have to weigh the cost, power, consumption, benefits of all of this stuff.
And you mentioned a couple of interesting points. I think the Things Network is really cool because there is quite a lot of base stations all around, right? Like I remember seeing the map. I think it was last year at their conference. They showed the map of the world with all the different open gateways, and it was quite interesting actually how many there are. Yeah. And then the other point that you mentioned about power, it's interesting because you're talking about Raspberry Pi here, so you're talking about an SBC effectively.
Yep.
So I usually hear the people talking about power efficiency when it comes to using LoRa in the context of microcontrollers, right? Because on a microcontroller you're usually trying to save power to running off
power
a battery.
possible. And it's kind of a nonsense with Raspberry Pi because all the other parts of the SBC are using so much power compared to LoRa that wanting to save just a tiny little bit of energy by using LoRa doesn't make that much sense. If that's the point you were trying to make,
it's just I guess in terms of an SBCs, you're already burning a lot of power. So I think LoRa, it's less because of the power, I guess, right? If you go to a microcontroller, it's a lot more because of the power, right? That you choose LoRa over something else. So it's interesting.
We'll also work with microcontrollers, which is kind of handy because you can have a lot of microcontrollers linked to some sensors, gathering data and just sending them to Raspberry Pi. Also hosting LoRa hats, but then which will have a big source of power compared to the little microcontrollers sending the data.
We need to do another presentation next time, Bruno, with microcontrollers instead of SBCs. And we need to look at what do we do instead of containers in the microcontroller world.
Oh yeah, I know somebody who could do that. Yeah. I think I will get help from a friend. Call a friend and see what we can do. Okay.
Cool.
Back to it. There we go.
Yeah, why not? So we have seen earlier quite quickly that Raspberry Pi could be used for AI with TensorFlow, for example. So of course there was also a Docker image for that. You remember that advertisement a few years ago? There's an app for that, but for just about everything, there is Docker image for that. So could we use our out-of-the-grid, somehow internet-linked, Docker-able ARM SBC to process the data coming from the edge of the real world? Yes, we can. So first of all, you have to train a model, so in the cloud or on premises, and then you will be able to run it on the Raspberry or on any SBC able to run Docker. You can use, of course, some more powerful boards like the one with the Rockchip 3399 to get more accurate results or faster results, but you can do even better. You can also add hats to the SBCs that will bring inference for models in areas such as predictive maintenance, anomaly detection, or robotics, and many more. You can find hybrid boards with programmable logic that are able to do much better than only with the CPU. Like, for example, this one is capable of 69 images processed per second compared to only 2 images per second with just the CPU. On the other hand, you also have cheaper and more specialized boards like the ones which are bundled with a camera that can do some image recognition, for example, thanks to specialized ARM libraries. You also have cameras that support the same SoC that some SBCs with AI extension chip NPU, like the Rockchip 3399 Pro. And speaking of the 99 Pro, it's the same as the RK3399. People who already follow me on Twitter know that I'm in love with that SoC, even if it's lots of it's not the perfect SoC, but I love it. And the Pro is the same one, except that we add on top of that a 3 TOPS performing neural processing unit. So it supports TensorFlow, TensorFlow Lite, Caffe, and other deep learning models. So as I said before, machine learning development is done most of the time in 2 stages. So as for TensorFlow, the recipe, an algorithm is initially trained on a large set of sample data on a powerful machine or on a cluster. Then the trained network is deployed into an application that needs to interpret real data. So this deployment stage or inference stage is where edge computing is really useful. So for the board with an NPU like this one, you have an intermediary step, a third one, which converts the trained model into something which is understandable by the NPU. So it's the case for this board is the case for the Orange Pi 4B, for example, for all the boards that have an NPU on the board to help the CPU and the GPU. So let's say now that you already have an SBC which is good at taking pics, for example, or getting sensors data, but which fails at inference because if it has poor performance. So you want to keep it because the time you invested in it is valuable, and that you don't want to invest into another one and redo everything despite using Docker. But what if there was a way to run something at the edge of your edge computing device? Could we call that the dangling on the edge computing? Just kidding, but not at the edge. But what if we could delegate the work to a specialized piece of hardware that we could link to the aging SBC? For example, this USB stick is the Orange Pi AI stick that supports Caffe, PyTorch, and soon TensorFlow. It can achieve up to 5.6 TOPS, almost twice as good as the RK3399 Pro. That's pretty impressive little piece of hardware. Now, Google has another proposal. I'm sure you already heard about that. Make any Linux or Android things machine. Android thing is dead, but anyway, even the Raspberry Pi AI-able thanks to their Edge CPU machine learning chip. Plug it in and use a dev kit, and you will process ML inference data directly on the device. So this chip is a stripped-down version of the one Google uses to train machine learning models in their servers. Of course, you will have to train your model in the cloud beforehand, but that opens quite a lot of opportunities for low-end devices located at the edge. So nowadays, we see more and more SBCs equipped with a standard SoC, but which get help from a powerful integrated NPU, like in the Orange Pi 4B. So let's hope we will see more and more of this kind of boards in the near future. And I think also lately that there are projects like the one at Mozilla, I think it's called TVS, that takes models and compiles it directly into a machine code so that the boards can interpret with just the CPU with very good performance. So we're almost at the end. So to conclude, if you're interested in machine learning and already have a Raspberry Pi gathering dust, as we all do, or stuck in your pocket, wait no more. You will find tons of tutorials for this card, but you can also follow more general introduction to machine learning or go to the Discord ARM server, Robert, to discuss ML and everything ARM. If you don't own a Raspberry yet, You could buy an even cheaper card like the Range Pi 1, which starts at €9, and start playing with TensorFlow in Docker or OpenCV. Yes, you can start machine learning and edge computing for about €9. You got it. I'm cheap. If you just want to start interacting with the outside world without machine learning, that's perfect too. If you're using the Raspberry Pi, you will find the biggest community that will help you progress. And if you choose another card, well, you have tons of fun chasing the little gremlins. And by doing that, you will also learn a lot and deserve a cold brew afterwards. The only rules at all are just having fun and learning on that. And the only limits are your imagination and the memory, USB bus bandwidth, SD card. Shh, don't you be so bitter. Anyway, thanks a lot for your attention. I will take all the questions you have for me. I don't have all the answers, but I will take the questions nonetheless.
Thank you so much, Bruno.
Yes.
You're welcome. Thank you so much for having me.
This was good. I mean, you actually, it's good because you built the whole story from the beginning to the end, right? And really good presentation.
Thank you a lot. The way you.
I loved it. I love it. I was telling you in the green room before we started that people have told me already. So many people have told me how amazing your presentation was at Lenaro Connect. So I mean, it was one of the things like we got to get Bruno on Innovation Coffee to share this with us as well.
You. Thank you so much. Yeah,
and you all got to see the extended version of this, so that's really cool. You did mention the Discord server, so I want to put this up there. Bruno is one of our lead developers in the Discord server, so he's got the blue handle, and you'll find him there under Podinga. Join us on there. And if you have more questions for Bruno after the show, after this is over, you can find him in there pretty much all the time. Yeah.
Yes, indeed.
So we did run a few minutes over the hour, but it's okay. It doesn't mean we have to immediately stop right now. We would love to give you still an opportunity. If you have any last words or something that you'd like to share with the viewers before we give our closing words.
No, if we're already late, we won't do a what's on your desk section. That's okay. No, it's too late, I guess. And most of the things I have on the desk are already plugged in. And so I won't be able to show you. I just have a few boards that I didn't plug in today. So I could show them. But there is nothing totally fancy and new. And everything I would show, you already know about it.
We did kind of do it on the fly. We put up the banner for a second and then we lost it, but we kind of did do it. So yeah, I think we can do it again though. We can do another. Let's do it official. Let's make it official, right? Innovation Coffee Kids. There you go. You're up.
All right, you're up. What's on your desk, Bruno?
So the boards that are not plugged today are my Renegade Elite. I don't know how it's supposed to be pronounced. So it's an RK3399 board. Oh, how surprising. It's a board that I do love. My kids used to use it until a few weeks ago when they upgraded to a real size computer. It's a real computer, don't you get me wrong, but it's just a little bit small. I love it. That's the board I started with Rosetta at home. I don't know if anybody in the audience started Rosetta at home.
Yes.
Yes. A lot of people, I'm sure, are in the audience who did that.
Yeah. So when I run Rosetta at home on this board, it's burning hot, but I love it. What else do I have? Sorry. I hope you're not seasick because it's moving. This is a beep. TV box, which I hope to transform into an Ambient board, but the power supply is not good, and there is no heatsink, and so it's just junk. One I love. Just a second. I don't know if many of you have that. It's a NanoPi Fire 3 with its optional touch screen. It's a beauty, and it works beautifully. I told you about the Android device farm I was running at work. So it's a bunch of real Android phones connected to a Raspberry Pi or any other SBC capable of running Docker anyway. And this board is capable of hosting this server of an Android device farm, but also can be used as an Android device in the farm. So I love this one really, really much. It helped me quite a lot to progress on that project. What else do I have? Oh, is it? No, it's not this one. It's not this one. It's this one. It's a very small one, which I love. It's a Rock Pi S. It's tiny. It's cute. And with all these colors, pretty fun. I talked a lot about the Orange Pi Zero. This is one of my preferred boards, I may say. And I told you I was in love with the RK3399. So here is the board I worked the most with. So it's the Orange Pi RK3399. Pretty complete board, and I tried lots of things regarding HDMI input and video encoding on this board. As a RK3399 is supposed to be able to encode 1080p, but for the time being, I have not been able to do it with FFmpeg. So I wrote a few articles about that, and the status is it just doesn't work, for me at least. Anyway, end of the section, if you don't mind. Do you have anything on your desk that you would like to share?
Me?
Yeah.
It's all behind me. Unfortunately, nothing on my desk. I mean, I have some boards.
I've got a couple of things. I think it's probably. I mean, everybody probably already knows about it, right? Like something cool has come up today. Look at this. Wait, let's see if I can get it.
Oh, that's not fair. You're in Cambridge, so you have access to that. Okay.
Wait, it doesn't.
He doesn't want to focus, but I think people got what it is.
I think everyone knows what that Raspberry Pi logo is.
Raspberry Pi Pico. I mean, it's tiny, and what's exciting is that next week we have the Raspberry Pi team on the show talking about the Pico board. So it's I'm excited. It's going to be a fun show.
I am too.
And,
yeah.
We actually put out today a guide on the Raspberry Pi Pico. So if you got, let me just share the link. Let me just share the link with you guys. We put a new guide out. The guide is gonna be out soon. In the meantime, we've got a demo video. So yeah, here we go. I'm gonna share it on the chat as well. So yeah, it's some exciting. I mean, it's got some really, really exciting features. It's a dual core Cortex M0 Plus. So it's quite an interesting board actually. And yeah, check it out if you haven't checked it out yet. And actually, I'll show you another thing I've got on my desk. Two things actually. Has anybody seen this? Where is it? Oh, the opposite. Oh no, sorry. Here we go. Portenta. Have you guys seen the Portenta H7 board and the Vision Shield? So we have actually Massimo Banzi from Arduino with some other folks from Arduino on the show after next week, talking about the Portenta H7. So make sure to check that out as well.
I think, Alessandro, that Bruno should get a Pico.
No, I don't deserve it. I'm in a love-hate relationship with the Raspberry Pi. I don't think he loves me enough to get to my home. Yes, you can send me one. I know what to do with it.
I mean, if anybody else, let's put it out there. Actually, if anybody else, has a cool idea, some cool project to build with the Pico board, well, let us know. I mean, reach out on Discord, and we might be able to send one your way.
The project is better than the one I'm thinking of. I will gladly offer mine to the project that is better than mine. Go ahead, give us your ideas.
Bruno, you've got a Pi, you've got a Pico now. Like it's done. So we just have to see if there's anyone else that deserves one.
Okay,
awesome,
cool. All right, so
great to my 3B. Anyway, sorry, you're about to go on.
No, perfect. I think we have to close out the episode now, if y'all don't mind. we did go over by 10 minutes, and I want to make sure we are conscious and very grateful of everyone out there. Your time is very valuable. We understand that. Bruno, gosh, thank you so much. I mean, we really appreciate this and, making the time to come on to the show, show us this amazing presentation. Very grateful.
My pleasure.
Thank you. So on behalf of ARM and Innovation Coffee, Bruno, thank you. All the viewers out there, thank you very much. Passing it over to my wonderful co-host to give his thanks. Alessandro, to you.
A big cheers to Bruno for being here. It was a pleasure to have you here, and thank you to all our viewers. It was fun.
I'm going to take a sip of this cold coffee.
Yes, looking forward for next week.